In this video, we're gonna have two problems. So the first problem is to find the equation of the curve that passes through point at a given point and at given slope. So given us a point and given us the slope, and then he wants to find the equation that passes through this point and that has that slope. Okay, so find the equation of the curve that passes through the point 1 and 2 and has a slope of 3 plus 1 over x y at any point. Okay. So we have the point is 1 and 2. And the slope, so we say dy dx, which is the slope, right, is equal, right here, 3 plus 1 over x y. Okay, let's replace. Let's switch those here. So it would be dy over y equal 3 plus 1 over x. So it's basically the same. We didn't really change anything. Okay, let's take the integration for both sides. So it will be integration of dy over y equal integration 3 plus 1 over x. This is y. Yeah, that's dx here. Dx. Okay? So 3 plus 1 over x dx. Take the integration of 1 over y, natural log of y. So that would be natural log of y equal to integration of this. It will be 3x plus integration, the same thing. So natural log of x plus c, constant, right? Great. Okay, now, so we want to, how we get the y from here. So usually we take the e function, so e value for this to be able to get the y. So it will be e natural log y equal to e, the other side, 3x plus natural log of x plus c. All right, so e to the natural log of y, that's equal to the y, equal to. Okay, so e to the c, that's a c. So that's the constant. So it will be constant. I'm going to call it c1. E 3x plus natural log of x. Okay, so far so good. Now, we want to know what is the value of c. So we have already a point here. It's given us 1 and 2. So let's substitute at 1 and 2. Let's see what's the value. So the y value is 2 equals c1 e, x value is 1, so it will be equal to 3 times 1, that's 3, plus natural log of 1, that's equals 0. So plus 0. Okay. All right, great. So that will be equal to c1 e to the 3. Right? 2. Now we want to know what's the c1 value. So we have 2 is equal c1 e to the 3rd. So if we say 2, get this down here. Same like over 1 equals c1. So c1 will be equal to e to the negative 3. All right. So c1 equal to e to the negative 3. That's the value of my c. And let's substitute this, go back to my y equation, which is the one has this one. So y will equal 2e to the negative 3 e 3x plus natural log of x. Okay. So how we do this, simplify this. So we have e and we have e, right? So we can do, say, 2, we combine this. So e 3x plus natural log of x minus 3, which is going to be equal to e natural log 3 natural log of x time e to 3x minus 3, right? So that would be equal to t2 we have here. So we said natural log of 1 equals 0, e to the natural log of y equal y, and e to the natural log of x equal x. So e to the natural log of x, that will be 2x e to the 3x minus 3, or we can even simplify more, e to the 3x minus 1. Okay, and that's going to be my equation that passes through the point 1 and 2, and the slope 3 minus 1 over x y. Already? All right. Let's have another problem. Similar one. Okay. So this one said find the coordinates of the point on f of x equal 4 over a square root of x that is closest to the origin. Okay, so this function here, so if we graph this function, so it's like this. All right, so this is y, x. So what's asking, the point is closest to the origin, it's 0 and 0. Which point on this graph is closest to the origin? All right, so this point, the distance consists of x and y. Each point here has x and y value, x and y value, x and y value, right? So this point, to get it, there is an equation for this point, which is d squared equal to s squared plus y squared. All right, so which one on that line closest to the origin? That's what we're trying to do from this given information here. All right, so basically that this point, it get closest to origin when the change and basically and change of that distance in dx closest to the 0, right? When the change is equal to 0, that's the one basically the point is on the origin point itself. So that's what the strategy we're gonna follow here. So we say we have f of x, okay, which is y equal 4 over the square root of x. Okay, so let's square both side. So y squared 16 over x. Okay? And then we set the equation here of the distance. D squared equal x squared plus y squared. So substitute for y. So it will be x squared plus 16 over x. All right? So final equation here in terms of x plus 16 over x. So the closest to the origin when d over dx, d squared is basically equal to 0, right? So when the change of this distance is like on the origin itself. So let's substitute for d squared right here. So d over dx, x squared plus 16 over x is equal to 0. So d over 2x is 2x plus 16 over x. That's exactly like 16 over to the x minus 1. So it will be negative 16 x to negative 2. So it will be negative 16 over x squared. All right. So that will be, let's substitute here. Negative 16 over x squared equal 0. So 2x equals 16 over x squared. So 2x cubed equal to 16. So x cubed equal to 8. So x equal to 2. All right, we got the x value. So we can go back and substitute to get the y value. And from the original equation, which is right here. Y squared equals 16 over x. 16 over 2 equal 8. So y will be equal the square root of 8, which is equal to square root of 2. 2 times 4 to the square root of 2. So y equals to the square root of 2 and x equals 2. So the closest point is x is 2, y 2 square root of 2. All right. So x is 2 and y is equal to square root of 2. All right, there you have it. Okay, so if you like that video, please like, share, and subscribe. Thank you very much, and see you in the next video.